Hey, 8th grade, Catlin here with your cool down help for lesson 5 where you're dilating these triangles. Your task here is you have to describe the dilation and be sure to include all the information that someone's going to need to be able to perform this. The dilation is taking the smaller triangle and dilating it to the larger one that's there. So your task is to give the 3 bits of information that's needed for dilation. So let me make me smaller. I need to be smaller anyway. So the 3 things that you need to provide for this: number 1, you have to give them what the center point of dilation is. Number 2, you got to tell them what the scale factor is. And then number 3, you also have to tell them the original coordinates of the shape that you began with. Okay, so I'm going to start off this sentence with to dilate triangle at coordinates. All right, let's give the coordinates here. Our coordinates of our original triangle are 2, 0. And then we have another point down here at 4, -2. And another point right here at 5, 1. So I don't need the word 2 there, I guess. We're just dilate triangle at coordinates 2, 0, 4, -2, 5, 1 with a center of, our center is the point on here that's plotted but not labeled. That would be this one at 3, 0 of 3, 0 with a scale factor of blank. All right, we finished that blank. We've got what we need. We've got the center taken care of. We've got the scale factor ready to be taken care of, and the coordinates of the original shape. So we got everything that they need to make a dilation. We just got to figure out, okay, how much bigger did they make this? So a couple of different things that you could do. One thing that you could do is you could look at the sides. If you had a ruler, you could actually measure how long this is and compare it to how long the corresponding side here is. And you could do a simple division to find out how many times bigger that it is. That's really simple. Another thing that you can do, and I think this is probably the more simple of the 2 things, is you can find the center point and extend a ray out from it that goes to one of the points. And luckily, this one down here on the x-axis is nice horizontal line, so you can count it really simply. So I've drawn a ray out here, and from the center, which is right here, from the center, the original dot is 1 away. It's 1 away from the original. So I can make a little table for this. I'll say, okay, here's my original, here's my new. Okay, my original is 1 away when my new is 1, 2, 3 away. My new corresponding point is 3 away. Now, I only need to do that for one pair of dots that are in this dilation because all of the other ones should be proportional. If I went out and did it with this one, it would have that same proportionality, and this extension would have that same proportionality where it's a 1 to 3 ratio. So if it's a 1 to 3 ratio, that's a really easy constant of proportionality to get from one side to the other, and that constant of proportionality would simply just be times 3, which means that my scale factor is times 3. You'll notice that this triangle right here, this smaller one, is 3 times multiplied by itself to get the larger big one. So this is like a 1 to 3 ratio in size all the way around. And so that's how we find that scale factor. We can look at distance from the center from any of the points that are on there, and then look at that ratio of what it used to be in the original to what it is now, and that constant of proportionality is the scale factor of your new shape. And that's all you need for lesson number 5. Hope it was helpful. See you guys.